Hey guys, in this video we will learn how to use Thevenin's theorem to solve any circuit. Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with a resistor RTH. Okay, hold here. Please check the below circuits. There is a left side one, right? This is the two-terminal circuit. This is any linear two-terminal circuit. Okay, there are two terminals A and B. So this can be replaced by a voltage source in series with a resistance. That voltage source can be called as VTH, Thevenin voltage. RTH can be called as Thevenin resistance. Okay, so this is the Thevenin's theorem. Thevenin's theorem states that any linear two-terminal circuit can be replaced by a simple voltage source and resistance, but both are should be in series. Okay. Okay, now see the circuit, and first we will read the question. Using Thevenin's theorem, find the voltage equivalent circuit to the left of the terminals. Terminals are A and B. We have to find the Thevenin equivalent circuit. After that, again we have to find a current I. Okay, now I will explain you clearly and easily. Just please follow my steps. Okay, step 1. Draw the Thevenin equivalent circuit. You know that Thevenin's equivalent circuit is simply there is a voltage source in series with the resistor. Okay, there are two terminals A and B. This is the simple Thevenin's equivalent circuit. But you have to aware that this voltage source can be called VTH, R is called RTH. Okay, this is the Thevenin equivalent circuit. But here you don't know what is VTH and what is the value of VTH and RTH. Okay, for that we will go to the step 2. First find the RTH. Okay, RTH means Thevenin's equivalent resistance. Okay, this is the Thevenin's equivalent resistance, that is RTH. Now we will see how to find RTH. For this we have to redraw the given circuit. Okay, for this we have to redraw the given circuit by replacing the sources with their internal resistance. If you remember, in previous classes superposition theorem, we replaced the sources with their internal resistance. Okay, I will tell you again. For voltage source we can replace with uh, for voltage source there will be zero internal resistance. For current source there will be infinite internal resistance. So for zero internal resistance we can replace by simply short circuit. For infinite resistance we can replace by open circuit. So ultimately what I'm saying is, for voltage source short circuit, current source is open circuit. Okay, I will redraw the circuit by replacing their internal resistance. Okay, please check here, this is the short circuit and there is a open circuit because voltage source and current source. So by replacing the given circuit with their internal resistance, the circuit becomes like this, and here we have to find the equivalent resistance across the terminals A and B, that can be called as RTH or Thevenin's equivalent resistance. Okay, RTH or R equivalent. You know, you are aware that equivalent resistance. How to find the equivalent resistance? So here if you see, 6 ohms and 6 ohms are in series and the resultant resistance will be in parallel with the 4 ohm resistor. Now R equivalent or RTH, that is equal to 6 plus 6, both are in series, that resultant will be in parallel with the 4 ohm resistors. 6 plus 6 is 12, parallel with the 4. Parallel means multiplication divided by the addition. So the resultant resistance is 3 ohms, that is RTH or R equivalent. So we will consider as RTH. From step 2 we found that one value in equivalent circuit. So we found RTH is equal to 3 ohms, and now we will find the VTH. So to find Thevenin voltage we have to redraw the circuit. Redraw the circuit means just we have to remove the load resistor and draw the open circuit. Okay, from this circuit we have to find the open circuit voltage across terminals A and B. So if you can find the voltage across AB, that can be called as VTH. Okay, here how can I find? So I will find the node voltage across 4 ohms. Okay, you can use mesh analysis also. Nodal analysis or mesh analysis, anything is fine. But to find this node voltage, I have another node. This is 1, this is 2. There are two nodes here. Okay, so I will use nodal analysis by applying Kirchhoff current law KCL at node 1 first. By applying KCL at node 1, V1 minus 12 divided by 6 plus V1 minus V2 divided by 6 is equal to incoming current 2. So there are two outgoing currents and one incoming current. So this equation can be considered as equation 1. Now by applying KCL at node 2, okay, then V2 minus V1 by 6 plus V2 minus 0 by 4. Okay, at node V2 there are only two resistors connected to the node V2. So V2 minus V1 by 6 plus V2 minus 0 by 4 is equal to, there are no incoming currents, so 0. So you can consider this as equation 2. By solving equations 1 and 2, so by solving above two equations, V1 is equal to minus 5.455, V2 is equal to minus 8.733. Sorry, there is a calculation error. This is not 0.666, 0.166 V2. Okay, so please resolve the equations with the latest values. Then you will get V1 as 15 volts, V2 as 6 volts. Okay. Okay, now from step 3, okay, from step 3, VOC or VTH, I mean voltage across the A and B is exactly the voltage across the 4 ohm resistor, because both are in parallel, right? So we can consider as V2 is equal to VOC or VTH. Now VTH or VOC is equal to V2 is equal to 6 volts. So this is the Thevenin voltage. Clear? You got RTH and VTH, so it means you know the Thevenin equivalent circuit. Okay. Now I will redraw the Thevenin equivalent circuit by adding the load resistor, because we removed the in initial step, right? So I will add it again. So what is the question? We have to find the current I flowing through the 1 ohm resistor. We know the values VTH and RTH. Now you can find current I easily. So I is equal to, what is VTH divided by total resistance RTH plus RL. Okay, VTH is 6 divided by RTH is 3 plus RL is 1 ohm. It means 6 by 4, that is equal to 1.5 amperes. Okay, so finally the answer I is equal to 1.5 amperes. So this is matching with the answers. I hope you can understand the problem. Okay, if you have any doubt, please comment in the comment box, or you can mail me if you have any new problem. I will solve in next video. Okay, thank you. See you in the next class.